Welcome to the Learning Assistant app YouTube channel. Have you ever wondered why the citric acid in a lemon provides a refreshing zing while the sulfuric acid in a car battery is dangerously corrosive? They are both acids, yet they behave in fundamentally different ways. To make sense of this, chemists don't just look at what an acid is, but how it's classified. Let's start with where they come from. Picture two distinct groups on your screen. On one side, we have organic acids. These are the ones we find in nature, in plants and animals. Think of the acetic acid in vinegar or the lactic acid in sour milk. Now, on the other side, look at mineral acids. These are inorganic, typically synthesized from minerals in a lab. Powerful names you might recognize, like hydrochloric or nitric acid, belong here. But how do we measure their power? This brings us to our second classification, strength. It's a common mistake to think strength is about how much an acid burns, but the real secret lies in its molecular behavior. Let's visualize two beakers of water. In the first, we drop a strong acid. Notice how every single molecule completely dissociates or splits apart, releasing a flood of hydrogen ions. In the second beaker, we have a weak acid. Watch closely. Only a small fraction of these molecules split, while most stay together. This ability to ionize completely or partially is what truly defines an acid's strength. However, don't confuse strength with concentration. Think of a glass of lemonade. If we have a lot of lemon juice and very little water, it's concentrated. If we add a gallon of water, it becomes dilute. As you can see in this diagram, concentration is simply about the ratio of acid to water, regardless of whether the acid itself is strong or weak. You can have a very dilute solution of a strong acid or a highly concentrated solution of a weak one. Finally, let's look at how many punches an acid can throw, a property we call basicity. Imagine an acid molecule as a carrier of hydrogen ions. A monobasic acid, like HCl, can release only one ion. But look at sulfuric acid, it can release two, making it dibasic. Some, like phosphoric acid, can even release three, earning the title of tribasic. By classifying acids through their source, strength, concentration, and basicity, we start to see the underlying order in the chemical world. If you want to master these concepts with more interactive visuals and practice problems, make sure to download the Learning Assistant app using the links given in the description box below. Let's keep learning together.